Alright, hello everyone. It's April 20th. Did not do anything I planned to do on Sunday. I planned to pick up C++, didn't do that. I planned to solve at least one of the hard problems that we didn't really solve ourselves last week, did not do that. Spent the day, actually the entire day, just keep writing a design doc. This thing is getting out of hand. I think that should be the end. I mean, it's been 3 weeks. 3 weeks. I did nothing but writing. And I think the worst part is whatever solution that we came up with for that design might not even work eventually. So I don't know. This whole thing is, but I I put I'm pretty determined that whatever design we have right now is going to be the one that we will implement for now. You can't just keep like analysis and analysis. This is no end, right? This is no end. You have to at a certain point just call it. Yeah, this is it. 3 weeks is more than enough to consider all sorts of possibilities. I think we did consider all sorts of possibilities. We did it simulation analysis, just kind of see how good the algorithm performs. I mean, from what we see, it's from what I see, it's good enough, and we should try it out, and then we can always iterate on top of it, right? That's the thing that we don't really. All right. So what does that mean? That means we'll start implementation. We have to. We have to start the implementation. But it doesn't mean anything for now. Now we just do our job. Count the hidden sequence. Zero index array of n integers. Differences, which describe the difference between each pair of consecutive integers of a hidden sequence of length n plus 1. More formally, call the hidden sequence hidden, then we have that differences I is I plus 1 minus I. Differences I and I plus 1 minus I. Okay, you are further given two integers lower and upper that describe the inclusive range of values, lower to upper, that a hidden sequence can contain. For example, if difference is 1 minus 3, 4, and lower is 1, upper is 6, the hidden sequence is a sequence of length 4. How do you know it's a length 4? Oh, because difference is a 3, okay. Whose elements are between 1 and 6, inclusive. So these two are the possible subsequences. Hidden sequences, okay. return the number of possible hidden sequences that there are. If there are no possible sequence, return 0. Okay. So we have 1 minus 3 and 4, right? And so we know 1, 2, 3, 4. That's what we have. And the lower is 1 and the upper is 6. Lower is 1, upper is 6. And we want to know basically this minus this. So if I said this is A, this is going to be A plus 1. This is going to be A minus 2. This is going to be A plus 2, right? Okay, so we can set this to be 1. And then trying to see what's the minimum that can be. Right? How do I see the minimum? Well, we have the basically the delta, right? So we have the delta is 0, 1, minus 2, and 2. So the minimum is minus 2. Maximum is 2. So if I get A to be, so I have lower should be 1, upper should be 6, which means the lower value, so not the lower value, but A minus 2 should be larger or equal to 1, and A plus 2 should be smaller or equal to 6. This gives me 3 smaller to A, smaller to 4. So the total number is 3 to 4, it's only 2. Okay, so now we're going to try this one. So this one is, again, we have A, let's just say we have, start with 0, right? And then we, well, plus 3, minus 4, plus 5, minus 1, and, wait, why minus 1? So plus 3, minus 4, plus 5, plus 1, my bad, plus 1, and minus 2, right? That's, so the total range, you'll find the minimum, find the maximum, and therefore the value should be between, I think it's lower minus this, so it's minus 3, right? And then upper to 0, so we have 4. Okay, so that's actually not very bad. I think it's pretty simple. We can code it up probably, I think, under 5 minutes. All right, so essentially what we have, we need the min and max. Min, int max, and the max equal to int min. Okay, and then the differences, right? Basically, it's differences. Should we say 0? That's actually 0. Hold on. Min and max, I think, should start with 0. Right? Because this is the min. It could be 0, it could be negative. Right? So now what we're going to do is saying for int d of differences, min equal to std minimum min and d. That is not true. That is not true. So we need a delta. Delta is equal to this. So delta will be plus equal to d. And then this should be delta. Max is std max. Max and delta. Alright, we keep updating the delta. Now once we get all that, min and max, then we should say we just update min shall equal to lower minus min, right? Because this plus this min should be larger equal to lower. So the lower minus min, upper, and max shall equal to upper minus max. count, right? Count. So rest shall equal to max minus min plus 1, because that's what we have. Max minus min 1 and minus 1. So we'll return rest is logical to 0, right? Rest otherwise will just return 0. Okay. I don't even know how to describe the solution for this one. Set, right, the first number to be x, then using the differences array we can produce the rest of the remaining numbers, right? The remaining numbers with regards to x, right? Find the min and max among them and restrict them using lower and upper. This can produce the range for x. If the range is reasonable, we can return the answer. We can return the number of arrays. Otherwise, we return 0. Okay, I don't think there's anything special. ON should be sufficient. All right, let's see. That looks solid. I am so sorry. I couldn't help. This is ridiculous. Only happens. Only happens. Yeah, I'm not sure. Things like this happen all the time. It does happen all the time because overflow. You're kidding me? Ugh. It's definitely not my network issue. Yep. This overflow happened from time to time. I think this is pretty simple. Most of people, I guess, will be able to figure this out. Oh. They use int. I am not sure if that's a good idea. Ooh, that is good. This is good. Holy crap. This is actually very good. I did not see that. You can terminate early. That's why you can use int. Gosh. Alright. That'll be it. Yeah, I have no idea if I have any gana to do any of this. I need to, but no, not today. Again. Alright, that'll be it. I'll see you guys tomorrow. Adios. I will do it like on the day that I don't work after coming home. Okay? That's when I will work on these problems. If, let's say tomorrow after I go home and I don't work, then I'll do it. But if I have to work then I don't want to do it. There's only so much that I think my capacity can take, right? Like if I work until, usually I go home and I work until 9 or maybe 10. It's not happening. Right? It's not happening. It's very hard for me to keep pushing after that. So that's kind of the thing. If I don't have to work, then yes, I'll do it. Anyway,